Now we'll see greedy algorithms. So an algorithm which uses greedy approach. So the problem definition will be like this. So you will be given a problem P, and the size of the problem is n, and you'll be trying to solve this problem P. That means you are going to devise a solution, you are going to devise an algorithm to solve problem P. You'll also be given a set of constraints. And whenever you devise a solution, you devise an algorithm, all these constraints must be satisfied. They must not be violated. All the constraints must be satisfied. Also, you'll be given an objective function, and you have to devise a solution to either maximize the given objective function or minimize the objective function. Now, maximizing or minimizing, that depends upon the problem, but you'll be given an objective function. You have to find a solution that either maximizes or minimizes a given objective function. So for any given problem P, there might be many number of solutions. They might be using divide and conquer approach, they might be using greedy approach, or not any algorithm approach, but you're solving it simply. There might be many different solutions. And there might be some solutions which use greedy approach. And among all those solutions which use greedy approach, any solution that satisfies the given set of constraints is called as a feasible solution. And among all such feasible solutions that either maximizes or minimizes the objective function, it's called as an optimal solution. So you need to remember these terms while you're talking about greedy approach. You'll be given a problem P, you'll be given a set of constraints and an objective function. You may try to find out many number of solutions, and all the solutions which satisfies the given constraints are your feasible solutions. And among all feasible solutions, the solution that either maximizes or minimizes the objective function is called as an optimal solution. Now, if I check a real life example, I want to travel from my home to college. That's the given problem. And the constraint may be time. I want to reach from home to college within 1 hour of time. So you have been given the traveling time of 60 minutes. That is the constraint. Now the objective function is you want to do so with minimum cost. That is the given objective function. Traveling from home to college is the problem. Traveling time 60 minutes is the constraint. The objective function is to minimize the traveling cost. Now there may be many solutions. You may walk, you may take an auto, you may take a bus, you might take your own vehicle. All these are feasible solutions. All these are solutions. But a solution which satisfies the traveling time of 60 minutes is your feasible solution. So if you walk, you cannot reach college within 60 minutes. It's not a feasible solution. If you take an auto or a bus or your own vehicle, then there are 3 feasible solutions which all satisfy the traveling time of 1 hour. Now, the objective function is to minimize the traveling cost. Now, whether you take an auto, is the cost less? You take a bus, is the cost less? Or whether it costs less if you take your own vehicle. Okay, so among the 3 feasible solutions, whichever gives you minimum traveling cost, that you'll take it as an optimal solution. Now, a greedy algorithm, the objective of a greedy algorithm is to find an optimal solution such that the objective function is satisfied within the boundaries of the given constraints. So your solution is said to be optimal if it satisfies all the given constraints and it either minimizes or maximizes the objective function. Now, the greedy method is the most straightforward and simplest design technique that you'll use to solve optimization problems. So most popularly, greedy approach is used to solve optimization problems. And what is an optimization problem? An optimization problem is the problem where you are going to find the best solution from all the feasible solutions. You may have many solutions. Among some of them will be feasible. Among all the feasible solutions, one of it will be the best. Now, finding such best solution from all feasible solutions, it's called as an optimization problem. And greedy method is most popular for solving optimization problems. Now, what does a greedy method do? Why it's called as greedy? A greedy algorithm makes a choice which is called as locally optimal choice. So the process of greedy algorithm goes like this, any greedy algorithm. Your end problem is solved in a set of stages, step 1, step 2, step 3, and so on. Your problem will be solved in number of steps, in number of stages. In each step, you are going to make a decision. And the decision will be a greedy decision. That's why this approach is called as greedy approach. Now, what is a greedy decision? At a particular step, I have many choices. And I'm going to choose one particular choice. And I have to make a decision. Now, what I'm going to do here is, at this particular step, at this point of time, I'll select whichever is the best choice. I'll not bother about the past. I'll not bother about the future. But at this moment, whichever choice looks best for me, I'll take it and continue to the next step. That is what is called as a greedy choice, which is a locally optimal choice. Now, solutions can be locally optimal or globally optimal solutions. What is a locally optimal solution? Now, as I said in before example, traveling. Traveling is from home to my college. The optimal solution is to take a shared auto. Maybe that's the best solution I have, optimal solution I have. That is locally optimal solution because that is optimal only for the given source and destination, home to college. It's locally optimal. If I change the source and destination, is it still optimal solution? It might not be. So a locally optimal solution is where it is optimal to the local scenario in space and time. So greedy algorithm always tries to find locally optimal solutions, assuming that finding a locally optimal solution may give me a globally optimal solution. This means that your greedy algorithm always picks the best solution at the moment. At this moment, I'm not going to consider the past. I'm not going to consider what are the consequences in the future. At this step, at this stage, I have some solutions, and whichever is the best solution at this step, I'll choose it and I'll go to the next step. After going to the next step, I'll have some choices. Whichever is the best choice at that step, I'll pick it and I'll continue. I'll continue till I find a complete solution. Then I'm going to stop. So this greedy algorithm, it picks the best output at each stage, best choice at each stage. That is, it makes a locally optimal choice. Hence, it is called as greedy approach. So in many problems, your greedy approach does not usually produce an optimal solution. Now you may ask me, if it is not producing optimal solution, then why we are using greedy approach? Greedy approach produces locally optimal solutions in a reasonable amount of time. So I may have a very large search space and solution search space. For a given problem, I'll have many number of solutions. And among all these solutions, I may have many number of solutions. I'll take a two-dimensional coordinate system, and I'm going to represent the solutions here. Some solution, another solution, another solution. So there may be many solutions like this. Right? Now, this is your solution search space. See, I want to find an optimal solution. That means I want to find the best solution that is available. How can I determine that among all the solutions, one is the best? Any one solution is the best. For that, I'll have to search for every solution, every feasible solution. These are all the feasible solutions. I have to compare what is the efficiency of solution 1 with the efficiency of solution 2, with the efficiency of solution 3. I have to compare the efficiencies of all the solutions. Whichever solution has the best efficiency, that will be your optimal solution. Now, if I have to find an optimal solution, I'll have to search all the solutions and find the best solution. That may take infinite amount of time, or that may take large amount of time. Now, I don't have so much amount of time to spare. I want to find the best solution in a given amount of time. So, in a reasonable amount of time, but still, I want to find the best optimal solution. It may not be actually optimal. It may be somewhat less optimal, but I'm fine with that. But I want to find a less optimal solution in a given amount of time. Then you'll go for a greedy approach, because greedy approach will not search the entire search space. It will not search the entire solution space, because it makes greedy steps. At each step, it will make greedy choices, greedy until limited choices. So I'm not going to search the entire solution space. So I'm going to find a solution within given amount of time, reasonable amount of time. But the solution that is produced by greedy approach might not be an optimal solution. It will be less optimal solution. But if you want to make a quick solution, then greedy approach will be suitable. Okay, so we'll study two types of greedy paradigms. I'll start with subset paradigm. Other one is ordering paradigm, which we'll see later in time. So the subset greedy paradigm, the approach goes like this. The problem has n inputs. So you are given a problem with n inputs, and you are required to apply greedy approach. And you are required to obtain an optimal solution. And optimal solution will be in terms of subset of n. So given n inputs, you have to find a subset of n inputs. That will be your optimal solution. And you should not forget that when you find the subset of n, it should satisfy all the given constraints. Now, greedy method suggests that you are going to devise an algorithm that works in stages. And in each stage, in each step, you are going to consider one input at a time. So how many number of stages will be there? If you have a problem with n inputs, considering one input at a time, you'll have n number of stages. You'll have n number of stages. One input you'll consider in each stage. Now I'll begin with an empty solution. Currently, initially, my solution is empty. Now I'll go through n number of stages and I'll try to complete the solution by finding a subset of n. At each stage, I'm going to select some input k. Among n inputs, I'm going to select one input k, any one. Now, which one I'm going to select, that depends upon a selection procedure. And this selection procedure is based upon an optimization measure. Okay, so in the previous example that I have given, traveling from home to college, the optimization measure or the selection procedure is traveling time, 60 minutes. That's the constraint, right? So this will be the constraint. Based upon the constraint, you are going to select an input k. Now, whether you can add this input to the solution or not, you have to make a decision. Now, if by adding this input k to the solution, if it's maximizing the objective function or minimizing the objective function, then add input k to the optimal solution. Otherwise, do not include k into the solution. So you are going to, at each stage, select an input k by using the selection procedure and decide whether you want to include this input into the solution or not, depending upon the objective function. Now you are going to repeat these steps. Next stage, select another input k. Decide whether this input can be included into the optimal solution or not. Third stage, select another input k based upon the selection procedure. Decide whether this k can be included into the solution or not. So you'll repeat these two steps until you find a subset of n, that is your optimal solution, a complete solution that satisfies the given constraints, as well as it either minimizes or maximizes the objective function. So this is the general control abstraction of any greedy method. Any greedy method you take, any greedy algorithm you take, these will be the steps that will be contained in a greedy algorithm. The greedy algorithm will be given an input problem A, which will contain elements from 1 to n. That means this array A, the problem A, contains n inputs. Initially, the solution will be null. The solution will be empty. You are going to repeat the greedy method for n number of stages. Because the input problem size is n, repeat the greedy approach for n stages, n times. In each stage, you are going to select one input from the given problem. Select any one input from the given problem. Now, how you will select? Based upon the select procedure. And let us assume that that input that you have selected is x. Now try to include this x into your optimal solution. And after including this input x to the solution, if it is giving you a feasible solution, it's nothing but you are either maximizing or minimizing the objective function. If your objective function is being achieved, then add x to your solution. So that is union of solution with x. Add x to the solution. Otherwise, you will not include X into the solution. So in each stage, you'll select an input from the given problem A. With the selected input, let us say it is X. Include X into the solution if it produces a feasible solution. Otherwise, do not include X into the solution. Repeat this for n stages and you are going to get an optimal solution after n stages. So a real life example for when you'll go for a greedy approach. So you have been given some coins with values 1 rupee coin, 5 rupee coin, 10 rupees and 20 rupees. These are the 4 types of coins you have with you. Now you have to represent 36 rupees and you have to use this. Determine the minimum number of coins to make 36 rupees and you have to use only these 4 types of coins. Now, the problem is representing 36 cents, right? So the given problem is 36 rupees. What is the constraint? The constraint is you have to use only coins with these values. What is the objective function? You have to represent 36 rupees using minimum number of coins. Using minimum number of coins. That is the objective function. Now you have to devise an algorithm. I have 1 rupee coin, 5 rupee, 10 rupee and 20. Now which one? I'll repeat the greedy approach for 4 steps, 4 stages. These are the 4 stages. Now in first stage, among the coins 1, 5, 10 and 20, which one should I choose? Right? So I may start by choosing the coin with minimum value. I may start by choosing the coin with a maximum value. So at least 2 types of algorithms, greedy algorithms, are possible for this problem. At each step, you may choose a coin with the maximum cost, maximum value. Or at each step, you may choose a coin with minimum value. 2 types of algorithms are there. So here I am showing the steps where at each stage, I am going to select a coin with the highest value. Okay, so now 36 is the amount that I have to form. Among the coins 1, 5, 10 and 20, I'm going to choose the coin with the highest value, which is 20. So the remaining amount will be equal to 16. So 1 coin I have chosen in step 1, stage 1. So this is stage 2. Stage 2, I have to choose another coin. So the algorithm that I have proposed, at each stage, I'll select a coin with highest value. So again, among 1, 5, 10 and 20, 20 is already done. The remaining coins are 1, 5 and 10. I'm going to choose 10. So 16 is the remaining amount. I have chosen a coin with value 10. The remaining amount that I have to include is 6. So in third stage, I'm going to choose 5. In the fourth stage, I'm going to choose 1. A coin, 1 coin with 20, another coin with value 10, another coin with value 5, another coin with value 1, which is equal to 36. Now at each step here, I'm making a greedy choice. What is my greedy choice? Among all the possible coins that are there, I'm choosing a coin with highest value. I'm not even bothering what are the remaining coins that are available. What will happen if I choose coin 1? What will happen if I choose coin 5? I'm not bothering. I'm just finding out among all the available coins, which is the coin that has maximum value. I'm selecting that coin and I'm going on to the next step. So I'm making a greedy choice here. right? So now this approach is what is called as a greedy approach. So like this, any given problem may be solved by using greedy approach, but not all problems can be solved by using greedy approach. Few can be solved by using greedy approach, few may not be able to be solved by using greedy approach.